Hey, good morning, everybody. How you doing on this fine Wednesday? I'm sorry, this snow day's got me all messed up. Apparently, I turned off the wrong alarm. So, sorry we're getting a little late start here. We got a couple things. We're going to get started in Chapter 4, and then we're going to talk about the lab assignment due today. And then we'll talk about that self-assessment for Project 1 as well. So, let's take a quick look at that. So we've got Lab 4 was due today, and then we've got Project 1 coming up due the 7th. So let's look at the project here real quick. So the idea with that self-assessment is it's your last chance here and your reminder to go look at the rubric and make sure, okay, I did this, check, I did this, check, I did this, check. So you're going to turn in the feedback pull request and that self-assessment. So just look at each of the items in the rubric and say, okay, hey, did I ask for the name? Use them for the prompts. I get 2 points. Hey, did I ask what type of food? Hot dogs, mini quiche, or dumplings? Okay, great, 2 points. If they didn't enter one of those, did I tell them you can't help and to try again? Yeah, 2 points. So you're just going down the list here. Now, there's no automated way to do it. It doesn't show up for you folks, unfortunately. It just shows up on my side for grading. So you can just say, like, number 1, I got the points, number 2, I got the points, or you can just copy paste it. Any way that you want to do, I just want you folks to get one last look at that rubric and make sure you think you're getting the points for all those things. And if you didn't get it completely done, that's okay. If it's totally gone, just say you didn't get it, no points. Or if you got it partially there, but it's not quite working quite right, say you got 1 out of 2 points or something, or maybe 1.5 out of 2. So feel free to also do some partial points there if you think you got most of it done, but not quite all of it. And that's all we're doing for that one, okay? Now our little party helper here. Does that make sense, SP Java? All right, let me grab Lab 4 here. Cool. All right, I got NetBeans fired up here. So let me close this out. And then I'll start up a Lab 4 project. Java with Ant, Java application, Lab 4. I'm going to make sure I put it in the right repository here. That's the Monday, Wednesday one. All right, so for this one, we're making our number guessing game. Right, so I gave you some starting pseudocode here to work with to say, okay, let's here's the general flow of it, and we're going to fill it in from here. Yeah, I'm looking at another tool. I can't get it installed on the virtual machines yet, so I didn't want to flip over to it right away. But IntelliJ seems to be working out real nice. So I'm going to, hopefully we'll be switching over to that. I can get our friend in IT to get it installed on the virtual machines for everybody soon. Probably not going to happen this semester though, because that sort of thing takes a while apparently, I guess. It's been a while since I had to manage like virtual machines. Hey, thanks so much for along. Glad to have you here. Right, so our general idea of this, right, was kind of step by step by step. So loops and loops, a loop inside a loop. So if we're going to be getting input from the user, we need that scanner. Again, I like calling it keyboard. You can call it SC like the book does, but I think that's a terrible variable name. You can say scanner given capital S system.in. And remember, Java's real case sensitive. Is it choppy? Let me see. Boy. I think it's NetBeans. I got a fresh restart. My computer was actually off overnight. I'm trying to be good about turning it off and not just letting it sleep. Yeah, that was NetBeans using up all my CPU. Microsoft Office click to run. I don't want to do anything with Office. I know, with the snow day it was confusing. Must be Java. If you want to take the day off and just come back and watch the recording, that works too. I don't want this click to run thing. Can we end that one? Because that's eating up a bunch. It ran like a hot plate, yeah. There, okay, now we got a little bit of room. Maybe. Hey, thanks so much for following along. Maybe. Maybe. Alright. Okay, I think it's settled back down. Yeah, it's not even NetBeans this time. I can't even blame NetBeans. It's audio device graph isolation. I really should have ordered that new laptop. I keep putting it off. I don't want to spend a bunch of money on a laptop. When this one, like, mostly works, but... Alright, is that less choppy now? Going any better, I think? I'm not dropping frames, so... I think that's going a little better. So remember, Java is very case sensitive. So if you do a lowercase s here, it's going to be real confused. And then all these suggestions are bad. Oh, okay, I guess if you do both lowercases here, then your suggestions are bad. None of them are the add imports here. Nice, Lido Star. Right, so you don't want any of these options here. Yep, Mohammed started earlier in Januari. If you do an exclamation point YouTube, I think I've got my YouTube channel where it's all archived. If you want to check it out from the beginning. So capital S, and now we'll get the suggestion for imports, and that's the one we want. So I saw a couple of people had some trouble with scanner. It's real sensitive to all these casings here. So, right. So then we'll ask if they want to play a game. Do you want to play a game? Sure. Okay. So we did that one, and then we need to get their answer. Right. So we'll have a string for, I don't know, we'll call it play. Is the keyboard.next line. So whatever they type in here, we'll grab it. Oops, I did a little format. I don't want that. Okay. I was trying to get these ones lined up here. We'll do that. Yeah, definitely. So while their answers, yes. So what we've done before, we said like, hey, if play.equals ignoring case, a y, we would go do something. But really, the only difference here now is that this becomes a while. We say, okay, while that answers yes, we're going to keep on going. Right? That loop we're going to keep on doing here. Right? Then, if you want, we can just jump down here, ask if they want to play again. I like doing that because then I'm going to make sure that my loop doesn't run forever. So if you're not careful, right, if you never change the value of play, your loop will run from the top curly brace to the bottom curly brace, and it'll come back up and say, hey, does this equal y? And yes, because you haven't changed it, it'll equal y. It'll run again. You get down to the bottom, come back to the top and check, does it equal y? Yep, run again, run again, run again. So the last thing we're going to do then is pretty much ask if they want to play again. So do you want to play again? And then we don't need this entire line here because it tells us the string play is already defined. And all that means is we've already told Java it's a string. We just need to say, hey, can you change the value of play to whatever they've typed in here? So whatever play used to be goes away. Okay, no problem, Red. That'll be just fine. So whatever value it used to be goes away, and now we play points at the new value we're storing. Yes or no, or whatever they've typed in. Oh, we should prompt them too, right? And say, how about a Y or an N? Make life a little easier for our users so they know what we're expecting. Doesn't mean they're always going to type it in, but we're more likely to get something if we suggest it. Okay, so that's where you ask if they want to play again, and now that the loop should at least work for there, and we can even try that. We can see, and maybe at the end of the loop we just say, have a nice day, have a great snow day, that sort of thing. Hopefully folks are staying safe. Let's give it a run. See if that works for us here. There's the link there, Mohammed. All right. So do we want to play a game? Yes. Do we want to play again? Yes. Do we want to play again? Yes. And as soon as we say no, the loop ends. So we can kind of see, okay, sure. Now at least the loop part here is working. Right? As long as we keep asking, right, keep entering a Y, we keep on playing. So we can kind of test it out a little bit at a time. Then we should ask them how high of a number they want to guess. How high number do you want to guess? Now this one needs to be numeric input. Right? So I need, this is going to be an integer here. We'll call it, I don't know, the highest number. Equals, now we can't just say keyboard.nextline. Remember, because keyboard.nextline is going to be a string, and it says incompatible types. String cannot be converted to int. So I can't store it as an int directly, so I need to convert it. I need integer.parseInt given the keyboard next line. Okay, now we've got the highest number. Now we need to generate a random number from 1 to that number. Remember, we use that math random, so I'm going to have an int for random number is equal to math.random. I'm going to take math.random, no, random, I had random, times the highest number plus 1. Remember, random gives you a number 0 to almost 1 as a decimal, so times the highest number will get me 0 almost up to my highest number. So adding 1 then will get me from 1 to the highest number. Now, Java is still mad, and this says incompatible types. Possible lossy conversion from double to int, because random has decimal places. So we need to turn this into an integer value. So we put it all in parentheses here. Then we can do that implicit casting. We can say, hey, Java, really, please pretend this thing's an int. I know I might lose some decimal places. I don't care. I'm happy with it. So this is that implicit casting from last chapter. Now we can have random number. Now we need to, we generated a random number. Okay. And we'll have to count the number of guesses it takes them to guess the number. So we'll ask them to guess a number. Guess a number, 1, 2, and then let's throw the highest number. We'll remind them what their highest number was, just in case. And then we need to get their guess. So their guess is going to be equal to, again, integer parseInt, keyboard.nextline. Because we wanted this as an integer value. Because if you're doing strings, I can't very well compare greater than or less than. I can figure out if it's equal to, but if I'm going to tell you if you're too high or too low, it's going to be a little bit of trouble here. Excuse me. So once they've guessed, then I'm going to count their guess. We'll have a number of guesses. We'll say starts off at 1, right? That was 1 yes. I should put my phone on quiet here. I don't know why it's beeping so much. Come on. There it goes. All right. Yeah, I don't worry about like weather sort of things, but we're just hanging out. So as long as I don't lose power, it should be fine. Hopefully you folks don't have anywhere to go. Okay, so we're counting the number of guesses it takes to guess the correct number. Great. We ask them to guess, and now this is that tricky next loop here then, as long as their guess is not correct. So, right, we're going to say while their guess does not equal the random number. Right, you've got equals, you've got not equals, you've got greater than, you've got less than. We've got a couple of these cool operators we can use, right? These are relational operators, right? How does one number relate to another? Or one value relate to another? So if it's not correct, then we can go tell them too high, too low. But then once it is correct, we'll tell them, great guessing. You got it in number of guesses. I'll bump that down a line because it's getting a little big here. Guesses. So tell them, okay, hey, you got it in. So if they got it on their first guess, we'll tell them you got it in 1 guesses. That doesn't pluralize right, but that's okay. Most people aren't going to get it on their first guess. So we can probably assume most people have 2 guesses or more. And we're just not going to feel too bad about it because that pluralizing things is weird. Okay? So then, as long as their guess is not correct, we can tell them too high or too low. So we can say, hey, if your guess is less than the random number will tell you too low. If it wasn't less than, it's got to be greater than. Because you can't be inside this loop if your number matches. Right? That's the idea here. So you're only inside the loop if the numbers don't match. So it's either then too low or too high at that point. And if you did another if or else if, that's okay. Not going to hurt anything. But, wow, I got some in my eye. I'm sorry. Oh, that's the worst feeling. I have to like squint to my screen. Right, so then we need to let them guess again. Right, so tell them too high or too low. We did our loop. Make sure that we count their guesses and have them guess again. So we can do the same idea here. Guess a number. Now we don't need to tell Java that guess is an int, and we don't need to tell number of guesses as an int. Now the other thing, number of guesses shouldn't be set to 1. We should increase by 1. So either plus equals 1 or plus plus. Right? I like the plus plus. Right? It just adds 1 to it. Give it a little format. So guess again. Get their number. Get number of guesses. So we're changing guess to make sure we probably won't be in an infinite loop because we got a chance here to change guess. Okay, let's give it a try. So how high of a number should we guess to? Let me know what you folks think. We can go as high as you want. Yes, we want to play a game. All right, it's an integer, so actually we're stuck about 2 billion or so, 2.1 odd billion, 1,000, you got it. Yeah, so if you edit the code, what I see is going to change. Yeah. That's okay. If you want to change it for the labs, that's okay. For projects, try not to change those until I've graded them, please. But the labs are definitely much more participation points, so I'm real generous with partial points. So as long as you're getting something in that's close, generally you're going to get all the points for the labs, is how that's going to go. Because again, ideally we would have had them done before you walked out the door. That sort of workflow. So I'm not going to be too particular on them as long as you gave it a good effort. Like if you just turn in empty code, you're not going to get the points. But like if you made a good effort, generally you should get full points for labs because these are your chance to practice these exercises. So if you want to go change your lab after, that's fine. I have no worries. All right, so let's split the difference. We'll take the middle. 500 was too low, so we'll go 750. That's too high, so somewhere between 500 and 750. So how about like 625? That's too high, so between 500 and 625. Let's do 575. That's too low. Okay, so between 600 and 575. So we're looking at 587 maybe. That's too high, so how about 582 is too high, so 579 is too low. So is it 581? Yes, we guessed it in 9 guesses. Look at that, number 1 to 1,000 in 9 guesses. Not too shabby. I used to give this to my little kids. They don't think it's as entertaining anymore. But years ago, I would give this to them and be like, hey, you want to play a game? And they just guess for, it seemed like a long time, but it probably was only like multiple minutes. And then the youngest would be like, okay, 1, 2, 3, 4, 5. Like, oh, sweetie, that's not how you guess. And yeah, let's play again. How about we guess 1 to 10? Right? 5, 3, 4. Yes, we got it. Yeah, brother's a great beta tester. For sure. So I was the little brother my older brother is 7 years older than I was, and he was into computers and programming and that sort of thing as a kid. I mean, I was a kid, he was probably a teenager. That's probably more what it was. But he would do cool stuff on the computer and show me. I thought it was the coolest thing. And then he went off and got a degree in computer science. It's like, I could go do computers. So, all right, we don't have to play again. And we'll say, have a great snow day. All right, so let me commit this to GitHub for you folks. And then we can move on to the new stuff. That sound like a good plan? We need the Monday, Wednesday. I was like, why doesn't it show any changes? There we go. Monday, Wednesday. This is lab 4. All right. Okay, so we got that. Close this one down. And we'll start up a new project. We're getting into chapter 4 now. All right. I really should just change those templates. But that's okay. One of these days I'll change it. You know, I keep saying that. All right. So chapter 4 is all about control structure. So we've looked at some basic if, else if statements, and we're going to look at some more advanced ones of those, and then we're going to look at other kinds of loops. It should be a lot of fun. So I don't know how far we'll get today, so we're not going to go too hard because we've got Monday coming up next week to finish up the chapter. So I want to start looking at a little bit more advanced logic here. So one of the things we're going to look at is how you can have multiple statements to make your life a little easier. So let me set up a scanner here so we can get some keyboard input. Equals a new scanner. Given system.in. Oops. And then let's look at that rock paper scissors game again, but let's make it a little more interesting, where the computer can actually randomly pick a value here. So we'll say, let's play rock, paper, scissors. Scissors. And now, what I want to do here is I want, I want this loop to run for sure. So I'm going to say my string for play, I'm just going to start it off as a Y here. I'm not going to ask them if they want to play a game. I'm just going to, okay, string is play. So then we can say while play equals ignoring case equals a Y. We can keep on going. So I'm going to set it to something that I know will make the loop run at least once to start. Then we can ask them if they want to play again at the end, right? Do you want to play again? Again. Y or no, yes or no. And then I can say play is their keyboard next line. Right, so I'm not going to bother with, hey, do you want to play? Right, we'll play, and then if you want to play again, we can do that. But this way I'm using my while loop up here. So we'll say, how about 1 for rock? Rock. We'll say 2 for scissors. Scissors. And then we'll say, oops, where's my curly brace? Semicolon. And 3 for paper. Okay, and then we'll get their input. So I'm going to use an integer for this because it's going to compare nicely to a random number. Okay, so we can get their, I don't know, the user throw is going to be integer.parseInt given the keyboard.next line. No, keyboard next line. Sometimes it gives me some weird suggestions there. Okay, so we got the user's throw. Then we need to get the computer's throw. Computer throw is going to be math.random times 3 plus 1. And I want all of that, right, as an integer here. So we're going to do that casting and say, okay, give it to me as an integer, please. Now I have the computer throw. So now, to figure out if we win, lose, or draw, the previous way would have had to be real slow. We would have said, okay, if the computer throw is equal to 1, then I can say, okay, if the user throw is equal to 1, print a tie. Else if the user throw is equal to a 2, if there's scissors and the computer is rock, then you lose, right? So if the computer's rock and the user's rock, they tie. If the computer's rock, and you can see this is going to get ugly, right? Pretty quick, because you're going to have 3 different of these and 3 different of these in here, right? Otherwise, then you win. And you don't want to have to do this, right? That's going to be really annoying here. Okay, so this is the old slow way. And actually, I'm going to comment all of that out here. So with a little comment block to leave it all gone here, because we don't want to do any of that old slow way stuff. We want to do the easier way. And to help remember how some of this stuff works, you get these things called logical ands and logical ors. So you have ands and ors. So I'll do this in comments too. So this is and. So if you say true and true, then the whole thing is true. If you say true and false, the whole thing is false. If you say false and true, the whole thing is false. And if you say false and false, the whole thing is false. It's going to feel a little awkward here, but the idea here is that with an and, it's ampersand, ampersand is our operator here, both sides have to be true. So when you go to McDonald's and that poor underpaid clerk says, "Do you want a burger and fries?" You say, "No, that's disgusting," because McDonald's fries are awful. You don't want a burger and fries. There's no flavor to them. They're like undercooked, and they're just like soft and soggy, and they're the worst. Nobody wants McDonald's fries. They're awful, right? So if they say a burger and fries, you say, "No, that's gross," right? So and both things have to be true. You want both things for the answer to be yes. Right? Both sides of an and have to be true to get the whole thing to be true. Okay? Now the opposite of that is an or. So if they say, "Hey, do you want a burger or fries?" And now the or is a pipe. It's the weirdest thing. It's the shift / above the enter key. So if either side of a or is true, then the whole thing is true. So true or true is true. True or false, the whole thing is true. False or true, the whole thing is true. But false or false, the whole thing is false. So if both sides are false, then the whole thing is false. If any of the sides is true, then the whole thing is true for these ors. So if I go in and they say, "Hey, do you want a burger or fries?" I say, "Yes, please. Give me one of those juicy quarter pounder with cheese, cooked fresh." I mean, they got me there because I was always a fan of Wendy's when they cook burgers fresh instead of pulling them off those little hot grills things or hot warming places. I'm happy to wait another minute to get my freshly cooked burger than to get one that's been sitting around for way longer than it should be, probably. I have little trust in the system that they're not going to serve food after they should be. Maybe they're better than that, and I'm just accusing them for no good reason, but I prefer if I thought the beef was cooked fresh. And it's actually kind of a tasty sandwich. You know, the quarter pounder with cheese, not too bad. Not too shabby. So with ors, right, either one is true, then the whole thing is true. Ands both have to be true, or the whole thing is false. So we can combine our logic here. So I can say, "Hey, if the computer throw is equal to 1, and the user's throw is equal to 2. So if the computer is rock and the player is scissors, right, that's going to be you lose. Right? Actually, the easy one here first is if the computer throw equals the user throw, then you tie. Right? And then else if, we'll combine those here. Okay, so now I have if they're rock and we are scissors, we lose. Right? Or if the computer throw is equal to if they're scissors and the user throw if we're paper. Right? So this and this, or this and this, or if the computer is paper and the user is rock. The user is 1. Right? So if they're rock and we're scissors, if they are scissors and we're paper, or they're paper and we're rock, if any one of those 3 combinations is true, so this and this, or this and this, or this and this. So it gives us a little bit easier way to do this logic because we can combine these. These are called logical operators. They operate on combining logic. So you either get true or false results out of larger things here. That's a lose. And if we didn't tie and we didn't win, or if we didn't tie and we didn't lose, you win. Right? So now we can play rock, paper, scissors against the computer, and it will randomly pick 1, 2, or 3. Let's give it a shot. Right, compile and save setting is the worst thing ever. Worst. All right, let's try it again. Oh, sure. Yeah, there's a link out in D2L if you want to go from there. In the content section, in course information. So if you want to get to any of the code I show, I commit all of it to the Github repository. This is the course Github repository. And you can see it all from here. So you can just browse around and go into any of those examples, click into the source, into the Java file, and then you can see all that stuff. So this was the stuff we did from chapter 3. Right, you can browse the repo. Does that make sense, SB Java? All right, so what should we do? How do we, let's try each of them and see if we can win, lose, and draw, right? So if I'm rock, we tie. Yeah, we'll play again. All right, I'm rock, we tied. Yeah, let's play again. I'm rock, we tied. Yeah, play again. I'm rock. Okay, we won. Great. So we were able to tie. We were able to win. Let's go rock, and now we lost. Okay, so we got each of the conditions. We won, we tied, and we lost with rock. Let's try again with scissors. So if I'm scissors, we tied. Okay, I'm scissors, we won. Okay, I'm scissors, we tied. All right, I want to make sure we can lose with scissors. We haven't lost yet with scissors. Come on, scissors. It's not usual that you want to lose at rock, paper, scissors. There we go, now we lose. Okay, so we got that for scissors. Now for paper, tie, paper, lose, paper. All right, we got to go for that win. All right, we won. So I'm feeling pretty good that those conditions are catching all of the proper possibilities here. I've tried each of them, and I can win, lose, or draw with each of them. Right? Now, the trick here, what we didn't really do, and that's okay, but you'll notice with the way that I have this logic written here, I have a way to cheat and to always win. You folks know what that is here? Do you know how I can always win the way I wrote my code? And it's specific to the way this code is written. Right? If you wrote it a different way, you might not be able to have a way to cheat to always win. So it has to do with this default else here. He said, if you didn't tie and you didn't lose, you must have won. So what's happening here is I'm only checking the user's throw for 1, 2, and 3 here, or if it matches here. That's right. So really anything other than a 1, 2, or 3. Good catch, Red. So if I put in a 4, none of these will be true because I'm not a 2 or a 3 or a 1. It doesn't matter what the computer is. I'm never going to match them. Yep, SB, that's right. So if I enter something that's not a 1, 2, or 3, right, I'm guaranteed to win because I didn't bother checking for it. So one of the things we're going to get to, I don't think we're going to get to it today, but probably on Monday, we'll get to looking at how I can make sure the user gives me a value that we want them to. Right, to make sure, okay, here is a particular value, and you have to give me one within range. You know, we can do that today. We'll cover that one today, because that'll make sense, I think. We can do that one for sure. We'll leave some of the other loops out. But so, yeah, let's run it, and let's try and give it a 4, or a 5, or a 10. right? So anything that's a number. So 4, and we win. Right, so what we want to do here is we want to set up another loop here. So I've got the user's throw here, and what I want to do here is I'm going to say I'm actually going to start user's throw. So I'm going to because I want this loop to run. All right, well, okay. I'm sorry. Let's jump back. So let's do it this way. So we'll get their throw, and then I want to say while the user's throw is less than 1, or the user's throw is greater than 3. So this is my invalid range. If it's invalid too low or invalid too high, right? Then I want this loop to run. And I can tell them, enter it again here. I can kind of copy paste it in. Now I just need to set user's throw. I don't need to redeclare it. So this keeps them inside the loop. So this is a validation loop. So input validation loop, right? We're making sure the input they're giving me is within a range that I want. So this defines what is invalid. So if it is valid, if it's a 1, 2, or 3, then neither of these will be true. And if both of these are false, false or false, the whole thing is false, and the loop won't run. Okay, now this will work. There's nothing wrong with this. We just feel bad about it. So let's give it a shot here real quick. We'll try it. So let's try 0. Oh, 1. Okay, and it worked. Play again, yes. How about a 4? It just asks me again, 5. Right? So it keeps on prompting me over and over and over and over. Now, what I don't like about this is that I have the same code in here twice, essentially. Anytime you have the same code, you should generally feel bad about yourself. That's a good rule of thumb. Is that if you've got it in here more than once, there's a better way, right? You shouldn't have to repeat yourself, because that's what we're looking at. We're looking at how do we use these tools to make sure I don't have to repeat myself. That's supposed to be a little bit of a joke, by the way, not like, please don't actually feel bad about yourself. Sorry. Sometimes I worry that's not clear. So what I want to do here, so if I don't want to have to prompt them twice here, I'm going to get rid of the prompt here, and I'm going to get rid of the input. And I'm just going to say, hey, it equals a 0. And a semicolon. You could. We're not to there yet, though, SB Java in the book. But for now, we can just put it in a loop, essentially. So I'm going to say, hey, the throw starts off as something invalid to make sure the loop runs. Right? If it's invalid, the loop will run. Now I don't have any repeated code. Right? I don't need to have the same prompt twice and ask them to enter a value twice. Right? I just started off with something that is invalid, so the loop will run. So I like this approach here, starting as invalid to make sure that you don't run into anything like having that same code twice. And the problem is, if you want to go change it, then you have to change it 2 places. So it's actually it's better than, I mean, I don't know what we would change here, but that's okay. 0 or 4 or 5. Oh my goodness, I need more coffee. All right, we lost. Yeah, let's play again. Let's do rock. We lose. Yeah, let's play again. Let's do rock. All right, we tied. Rock. We win. Okay, we'll end on a winning note here. So we won. Congratulations, we won with rock. Okay, how's that sound? So we can use this loop to validate their input. Now this is with numeric values. We can do it with string values too. So let's go down a little bit and say, I don't know, what do we want to ask here? Let's play a different game here. So let's play red light, green light. So then we'll ask them to enter. So please enter red or green. Right, and then we need to get their string or the color. It's going to be the keyboard.next line. Okay, and the same idea here, that I can make a loop here. I can say while my color dot equals ignore case. Now this one, it takes a little bit of different thinking here. So we're going to say while the color is not green. So not is another logical operator. It's not. So flips true and false. So not true is false, and not false is true. So if the color equals green, that would be true. Not true would be false. Right? If it does not equal green, anything other than green is going to be false. Not false will be true, and then my loop is probably going to run here. We're going to say, well, the color's not green, and not the color is red. So not green and not red. So it takes a little bit to think through it, and that's okay. These get a little bit funky here as we go. So if I were to enter purple, color equals green is false. Not false would be true. And does purple equal red? No. So that's false. Not false would be true. So I'd have true and true. My loop would run. And then we'll make them enter the color again. Red or green. Now, if they were to enter red, green is not red, so this would be false. Not false is true here. But then I would get, okay, does red equal red? True. Not true is false, and I'd have true and false. With an and, if either one of them is false, the whole thing is false, my loop won't run. So this is validation loop for strings. So each one of these essentially is just any of the valid strings. We're going to check, is it not this, and it's not this, and it's not this, and it's not this, and we can just combine all of them together with ands, because if it is one of them, my not here will flip that to false. Hey, thanks for following along, Goo Carry. Glad to have you here. And again, we can do that same sort of trick here, where we just say, hey, color is equal to, I don't know, it could just be empty. It doesn't really matter here. So I don't have to prompt them again. Right, so this starts as, so the loop runs. Okay, and then this not operator here. I don't know, should we put that like over here or something? Let's give that a try. So we're going to make sure that if it's not green and it's not red, we keep on asking. All right, so we'll do purple, do orange, we'll do yellow, and then we'll try green. And it works. So we get out of the loop. Right? So this keeps them inside that loop as long as they've given us something that is not a valid option for our strings. Does that make sense? Right, so we can do those validation loops. We got some cool options with the validation loops there. Sorry, I'm just waiting for chat. Okay. Cool, so you folks are doing good. We're getting our way through here. We've done pretty well. I want to look at one last thing, and then I think we'll call it a day, and we'll save the rest for Monday. So let's do, let's actually add yellow in here. So yellow or green. I don't know. We'll add another possible light. So I'm going to add another and in here. So green or yellow or red. So if it's not green, it's not yellow, and it's not red. So any one of those can be valid. So when we're done then, I'm going to have this color. Now what we had done before, we would say, hey, if the color equals ignoring case green, we'll say go. Else if the color equals ignoring the case is yellow, we'll say, I mean, no one stops for yellow, so just go faster. That's a joke, though. And then else if the color, and really, I guess it could just be an else, but maybe else if is another, why not here? So I know it's going to be only one of those valid options, but it's not going to hurt anything to check here. So if it's red, then we'll say stop. stop. Okay, so go faster, or stop, depending on what kind of color we got here. So this is fine. I prefer if, else ifs, but there's another thing you might run into in Java or other languages called a switch. So a switch essentially can take the place of some if, else ifs. It can't take the place of all of them, which is another reason I don't like them. But if it's just, hey, we just want to match on this value, or match on this value, or match on this value, and do something with it, we can say switch. So we say switch on the color. And then, set of curly braces. Now, the other thing here, with switches, it gets a little funky. So we say case. And then you say, well, what is the case? So our case is green. So if color matches the case of green, then we can say go. Then you have to add this break keyword. So breaks are important. Breaks make switch stop. So it will just end the switch. As soon as it finds a break, it's game over, done. Switch goes to the bottom. We're done with the switch. And these are important because weird things happen with switches. We can have a case for yellow. We can say go faster and break. And then we can have a case for red. Stop. And then a break. Now, the problem here, when we were doing our comparisons with our ifs, we had equals ignore case. We don't have that with switches. So a capital G green is not going to be the same as a lowercase g green here. So two options then, right? So one's can't ignore case. So one option we have then, so when we look at color, we can say color.toLower and say, hey, treat this as a lowercase here. So we can't ignore in cases, so we're going to use this to lowercase to turn that color to lowercase, and then all my cases then can be done in lowercase. So that's one way to work around it versus using this equals ignore case option. So that generally works out okay. Not too bad here. And then if you want, you can have a default case here. It says, we'll just say, why it doesn't work. Now the print line, don't recognize, or I don't know that color. Now again, we know we did a validation loop, so we probably won't ever get here, but that's okay, we can add it in. And then defaults generally don't need a break because they're the last thing in the switch. You don't put defaults above other cases, so break is really optional here. And it'd be the same as having this up here, right, saying I don't know that color. Right? It's an else. It's the ending else here. It's the if it doesn't match any of the other ones here. So it acts the same as the above here. Right? So it works out, and it's not too bad here. Right? But now the problem is, if we were to do something like enter your percentage score, 1 to 100, and then we get an int for their score is an integer.parseInt of the keyboard.next line. Right? With if statements, I can say, hey, if the score is greater than or equal to 94, spit out an A. With a switch on score, if I'm switching switch on score, if I'm going to switch on that score here, I can't say case greater than or equal to 94. You can't do that here. That's no good. You could, if you really wanted to, you could say case 100, and then you could say case 99, and then you could say case 98, and then you could say case 97, and then you could say case 96, and then you could say case 95, and then you could say case 94. Now, remember when I said this break is kind of important because switches are weird? As soon as it finds a matching case, it will go until it finds a break. So this is another reason I hate switches. So once it matches a case, it runs until it finds a break. So case 100 will then ignore the rest of the cases, go run code until it finds a break. I think they're the dumbest thing ever. The switches drive me crazy. They just, I don't know, they behave weirdly. So you could do that, but again, who wants to do this when you could just say, hey, score is greater than or equal to 94? Else if my score is greater than or equal to 90. Right? That'd be A minus. So we could do some more cases in here, right? And then we could have case 93, we could have case 92, we could have case 91, and you could have case 90. A minus. Break. Right? This would be awful going all the way down, right? Especially once you get down to the Fs, right? Having to do case 1 through 63 or something, right? Anything less than a D minus, I think, is an F. That sounds awful, right? So a switch can always be replaced with an if-else, but you can't always replace an if-else with a switch, right? Just imagine if this was an even bigger range. If we're like, hey, give me numbers between 1 and 1,000, and then we did something with that, with a couple ranges here. That'd be terrible. So they're not always all that useful here, but some people love switches, and that's fine. If you like switches, go for it. It's no big deal there. It's it'll be okay. All right, so we got through switches, we got through validation loops, we got through our logical operators. So not is also a logical operator, right? This where we did nots here. So that's the other logical operator. So you have ands, you have ors, and you have nots for logical operators. Cool, you folks are doing great. So why don't we talk about the next lab exercise, and then I think we'll call it a day. We'll turn it over to you folks to work on the lab. And anything else you have left on the project. Does that sound good? And then hopefully you can enjoy the weather. You don't have to go anywhere is the hope. And maybe go get some sledding done. See how it goes today. So let me go over to my GitHub Classroom and set up another link here. And we'll start a new lab assignment. Come on, sign in. Let's do lab 5. And we'll make a new lab 5. Come on. Working on it. So this will be due next week, the 9th at 10 a.m. No, not 1 a.m., 10 a.m. There we go. 10 points for lab 5 in the lab category. In the lab category, text submission. There we go. All right. We're getting there. 2022 lab 5. There we go. Java template. Feedback pull requests, and we got our link. Just a couple clicks here. Submit the feedback pull request URL. Okay. So, for our lab, we want to do a little bit of practice with some of those validation loops and some of those logical operators here. That make sense? So we're going to do a couple things. So we're going to, let's see. So I'm going to ask the user to enter their score, 1 to 100, and use a validation loop to ensure they enter a value 1 to 100. Right, so make sure we're getting the correct, what we expect here, values 1 to 100. Okay? Then we're going to, let's see, we want to do some logical operators here. What do we want here now? Okay, and then we'll ask the user to enter the average score, 1 to 100. Okay, And then we got a couple ways you could go about it here. So either one would be okay. Again, validate the input. So we're going to do a crazy curve here. And we'll say if user score is greater than the average, tell them they got an A. The user score is within 10 points of the average. Tell them they got a B, and otherwise they get a C. So within 10 points, like meaning within 10 and below it here. Actually, we should determine. So if it's greater than the average, it automatically gets an A. And then if the average is less than an A, if they got within 10 points of the average, they get a B. If the average is less than a B, they got within 10 points of the average, they get C. So we got to kind of do these in order, right? So if it's less than an A, but not less than a B, right? So like if the average is a B, I guess I should say, is so less than an A would be less than 90, right? Less than a B would be less than 80. Right, so we're going to have some interesting logical operators here. And then if the average is less than C, what should we give them? Less than a C is going to be less than 70. If they got more than 50, you get a C. Otherwise, they get their score. So we're going to ask them what the average is. So ask them for their score, and then ask them for the average score. So trying to see, if the average was, if they did better than the average, they automatically gets an A. Doesn't matter what the average is. But then if the average was less than an A, if they got within 10 points of that, they get a B. Right, so if the average was in the B range and they got within 10 points of that average, we're going to bump them up to the B, essentially. If the average was less than a B, meaning like if there's a C, this is going to be less than 70, but greater than 80, greater than or equal to 80. Right? So we should say if the average is a B, okay, there we go, is a C, so it's less than 80, but greater than or equal to 70. And the average is less than a C, but they got more than 50, they get a C. Yep. So we're just saying enter value for your score, enter value for the average. So you just tell me those two things. Okay? And otherwise they just get whatever their score is. So just a crazy little curve thing here, but it should practice with some of those logical operators to check some of these different values here to see what's going on there. Okay? Does that part make sense? So that's what we're going to practice for the lab today. I'm trying to use some of those logical operators and do some of these validation loops for values 1 to 100. Cool. All right. We should be in pretty good shape then. I'll save that one. I'll quit this to GitHub. Here was chapter 4 started. So it's validation and logical operators. Commit and push that. So we've got the rest of today then to get working on the lab, wrap up any last things you have for the project. Don't forget that's coming due Monday. Right, so project 1 due Monday. We'll go over that one first, and then we'll finish up chapter 4 on Monday, okay? All right, if you folks have any questions, let me know. I'll be hanging around. You can email me, find me in Discord, text me. We can go from there, okay? All right, you folks take care. Have a good one.